7.3 Estimating a population standard deviation or variance. Key concept. This section presents methods for using a sample standard deviation, S, or a sample variance, which is S squared, to estimate the value of the corresponding population standard deviation, sigma, or population variance, sigma squared. Here are the main concepts. Point estimate. The sample variance S squared is the best point estimate of the population variance, sigma squared. Confidence interval. When constructing a confidence interval estimate of a population standard deviation, we construct the confidence interval using what we call the chi-square distribution. The chi-square distribution. Key points about the chi-square or chi-square distribution. In a normally distributed population with a variance, if we randomly select independent samples of size n and for each sample compute the sample variance, the sample statistic is chi-squared, which is equal to parentheses n minus 1 times the sample standard deviation squared divided by the standard deviation squared. Has a sampling distribution called the chi-square distribution, as shown in the formula below here. So here's the formula for the sample statistic. Now, critical values of the chi-square distribution. We denote a right-tailed critical value by chi-squared with the right subscript, and we denote a left-tailed critical value by chi-square with an L as a subscript. Those critical values can be found by either using technology or table A4, and they require that we first determine a value for the number of degrees of freedom. The degrees of freedom. For the methods of this section, the number of degrees of freedom is the sample size minus 1. So the degrees of freedom is equal to n minus 1. Now the chi distribution is skewed to the right, unlike the normal and the student t distributions. The values of chi-square can be 0 or positive, but they cannot be negative. The chi-square distribution is different from each number of degrees of freedom. As the number of degrees of freedom increases, the chi-square distribution approaches a normal distribution. So let's take a look here. Here's the graph below. If you look on the left, this is the chi-square distribution, and you can see that it's being skewed right. And all the values, if you see here, start at 0 and go all the way to the right. All those values are non-negative, meaning they can't be negative. And this is not symmetric. Now, as we stated up here, as the number of degrees of freedom increases, then the chi-square distribution becomes a normal distribution. So if you take a look at when the degrees of freedom is 10, that's the one that's in purple. And you can see here that it's a lot more skewed right. Now, once we increase the degrees of freedom to 20, now you can see that the one in green starts getting closer and closer to a normal distribution. Now, caution. Because the chi-square distribution is not symmetric, a confidence interval of the population variance does not fit the format of the sample variance minus the margin of error and the sample variance plus the margin of error. So we must do separate calculations for the upper and lower confidence interval limits. Now, if using table A4 for finding critical values, we're going to note that the following design feature of that table. In table A4, each critical value of the chi-square is in the body of the table that corresponds to an area given in the top row of the table. And each area in the top row is a cumulative area to the right of the critical value. So let me open this up here. So you can see here's the chi-square distribution. At the top, you're going to see that it says area to the right of the critical value, which are these values, 0.99 all the way to 0.05. On the left column, you can see it's the degrees of freedom, and everything in the body of the table is going to be the critical value. So therefore, that's going to represent the critical value. Okay, now also caution. Table A2 for the standard normal distribution provides cumulative areas from the left. But when we're talking about table A4 for the chi-square distribution, it uses cumulative areas from the right.